All right. Hello, everybody, and welcome to our discussion. Um, our session chair seems to have gone missing, so I'm just going to introduce everybody. We've got a couple of really amazing guests here today. So I'm just going to introduce everybody in brief. So Lucky, I met through working with JoziJS, and he works at BBE. And I know him because he works in the grad program there as well, which is fantastic. So hey, Whitney, I'm just introducing Lucky. You can take over if you like.
Sure, thanks. Sorry about that. I had to emergency change of locations. Cool. So Lucky Nkosi, I don't know how far you get, but he's got a degree in engineering and game design. He works at BBD as a software engineer, and is heading up the research and development unit and works with Wits' digital arts department. So very focused on game dev education, but also traditional software development education through BBD. Next, we have Tim Flusk, who is an associate lecturer at digital arts in Wits University, and he lectures in game design and game development. He is an International Games Fest award winner and has produced numerous games with all sorts of students, and loves training young developers and creating knowledge and research within the media and technology space. Then we have Mick Messerschmitt, who's a senior lecturer at the Department of Mathematics and Applied Mathematics at the University of Pretoria. He received a PhD in pure mathematics from Leiden University in Netherlands in 2013. And for a number of years, Mick has taught introductory scientific computing using Python for first-year science students at the University of Pretoria. And interestingly enough, also tries his hand at competitive gaming. He's been ranked ranked in 1v1 for Planetary Annihilation, and he does a whole bunch of arts and crafts. So pottery, furniture design, bookbinding, crochet. Nice. Cool. And then there's Sheena O'Connell, who is the most fabulous CTO of Umuzi, which is the most incredible technical education sort of code school I've ever come across. And I've had the great pleasure of actually working with her briefly at Umuzi. And Umuzi is a not-for-profit that really teaches people how to have high-value digital careers. She builds the curriculums, and she builds a whole bunch of software to help them manage the crazy amount of students that they have, and does a lot of technical mentorship, and I imagine just a lot of cat wrangling. Cool. So that's the panel. My name is Whitney Tennant. I am the founder and CEO of a software agency called Brave Orbit. We build apps for social and environmental impact-based organizations. Alrighty, so kicking this off, this is quite an all-star team of people who have, I think, with the exception of Mick, been professional software developers. Mick is definitely focused more in academia. And I think at least a lot of people attending this conference have had the experience of teaching young developers. And so the point here today is how do we support the people that do teach software developers in their team, and how can we discuss the way forward and the way to start promoting technical education in South Africa and globally. So it's a great privilege to have people like this in this panel. So we're gonna get to hear what everybody's thoughts are. Cool. So our first question here. All right. Lucky once told me, writing code is easy, building software is hard. What is the best way to teach people to build software? Is that best done on the job? Cool. I'm going to field this first one to Sheena.
All right. So I actually added that question because it's a damn hard thing to get right. So I train these junior coders and I teach them how all of the fundamental stuff works, and that's fantastic. And I teach them Git and I teach them testing and all of that. And then if I ask them to do something realistic, then things tend to fall apart a little bit and they need like even more guidance. And I think like teaching those foundational skills is something that we're pretty good at doing, like at like a reasonable scale. But when it comes to like actually building software, I don't know what the most efficient way is to get people to be able to do that without being like, okay, come, we're building a thing together now. Yeah, so I'm super keen to see what everyone else has to say. I suspect that Lucky probably deals with this a lot because of the grant program. Yeah.
If I could jump in there, yeah. From my own experience, yeah, coding is easy. The engineering part is hard to put it all together so that it doesn't break when you touch it over here, and it's a bit of a shame, and it's also it's not really, no one really knows where to put it in. For example, I did a lot of CS courses. I was never told about test-driven development. I was never told about, let's say, the solid principles, those kinds of things, and had a lot of projects. Luckily, my own personal projects that I could just throw away, but a lot of projects that you just can't progress any further because if you touch it, it breaks. And it just I'm still at that stage. I'm getting better, but it's so hard to build a large software system that doesn't break when you touch it.
Lucky, thoughts?
Yeah, it's a very interesting question. I think we rightfully so spend a lot of time teaching these fundamental principles of development and how to actually write code, and it's very important. But I think that's half of the teaching problem. I think the next step is to put in just as much effort into teaching how to actually put and build software from all of these tools. So I generally see programming languages, frameworks, and all of these things just as tools in a toolbox that we use when we need them in order to build products and these mammoth software things. So how we try to address this thing is when we teach, so our program is a year long, and every sort of 4 to 6 weeks, we teach something different. When we focus on that thing, say it's web development, for instance, half of that is dedicated to teaching and reiterating the language principles, best practices on how to use the language. And then the second half of it is actually given to the students or the grads rather, to actually build something out of it. What they build is inconsequential. We come up with different ways to make the theme exciting, but what we want out of it is for them to collaborate and actually build something. We then discuss straight after that on how this could have been improved amongst their peers, as well as sitting with the instructors and even invite some of the other experts across the business. And I think what this shows them is this exact same thing. And you can actually see the quality of what they built from the first project versus the last one. Right? There are a lot of things around security that we keep reiterating. And every time they think that they're focusing on Java this month, right? But what they're also building is solidifying these concepts of how to actually put together a solid system. So I think the same effort that we put into teaching them the language fundamentals and the frameworks and all of these things, we need to highlight just how important it is to understand how software comes together. And we need to put in just as much effort.
Cool. I think it must be like really nice to also for your developers to see the project from the start project to the end project. That must give a lot of students a lot of validation and a good feeling. I think a lot of teaching people how to code is like relatively unstructured. So I don't think people actually as much see their learning journey as much. That's cool. Tim, what are your thoughts?
Yeah, I think particularly listening to everybody else's response has been quite fascinating for me, specifically coming from the game development background, not necessarily the game software development background. One of the, as Lucky pointed out, there's this obsession on the focus on the code being the software from a junior's perspective. And literally they are just tools. And one of the things we had started seeing, even before we just start even talking about the software development component, is students' approach to understanding how to put a game together. So we start with board games. We start with analog. We don't touch software at all. And we specifically started seeing the lack of the understanding of being able to think and design systems before, whether it be utilizing cards or dice or this, that, or the other. And the refocus on system design is something we started pushing quite a lot more intensely recently, because there is that scenario where students don't focus on their game design and they just throw a bunch of code together and they believe they made a video game. I'm sure they are perfectly appropriate analogs to more traditional development. But because we get to focus just on game design, or rather our main focus is game design, that does mean that pivoting towards that more explicitly, what's your game design? Tell me that, and then we care less about your code because we trust that you're able to code at your level at this point, has produced more interesting things. It also has demonstrated to the extent to which how much harder it is. I think, as Mick mentioned earlier, writing code is pretty straightforward. It's pretty easy once you've spent a couple of years or months in it. Being able to use that to create meaning, whether that be data analysis or making people cry with your jump mechanic in a video game, is a lot harder. And I think this is why I think from the academics and specifically the art school perspective, there's that torched metaphor of code being made out of languages. And we try to demonstrate to them, these are your words, these are your grammars, these are your sentences, these are your paragraphs. There's something also quite interesting happening there based on what you guys are saying, where ultimately what we are doing is that meaning-making production process, which takes a lot of critical thinking, a lot of reflection, and all those things, and sort of reveals it's a thing beyond just software. It's a process of people being able to push beyond what they've thought before. I don't really have a good concluding statement, but those are my thoughts.
Oh, that's great. Should we jump into the next question? Getting a degree takes a few years, but alternative education takes a lot less time. What are the major differences in output and goals? So at Umuzi, we have a 1-year course, which isn't a lot of time. So we take somebody who doesn't know any coding, and then we teach them all of the basic tools. And now they can code, but they can't necessarily build software. And I think, like, hearing you talk, Tim, it sounds like you are looking to build people who have that like higher level of understanding, or like of software engineering, or like a better conceptual framework. What other major differences might there be? I think, like, also from my perspective, my goal is to get people to be work ready. So that's why we teach things like Git. It's like, okay, junior dev, when you go to your first job, you're going to use this tool. And if you don't know this tool, you're going to just hit your head on it for 2 weeks and annoy everyone. So, like, let's get that done now. So, but you're not necessarily looking to get people into their first job, even.
And I think I'm gonna at some point push over to Mick as well, because I think he's going to provide a significantly more longitudinal idea of like what the point of a university is. So those things that you mentioned, it became an ethical mandate for us that we do need to have people be work ready. because people are paying a lot of money to go to these degrees, and they need to be able to live and become upstanding citizens. I think, though, the important consideration here is that above that ability to create and make and work, there are fundamental sort of pillars that are ingrained into at least my department, and maybe the wording changes based on where you are. But it is also about preparing people for the ability, for example, to go into academia, to be able to engage and investigate and evaluate and assess the knowledge that has come before us and the ways in which we got that knowledge, to eventually start producing their own knowledge, to be subverting the knowledge that is currently already available to us. Just in a sense, the type of output and work and graduate that you want, on top of being able to build everything, is about their ability to understand the contextual significance of what they are doing. So that's the short answer on like what we are trying as a university and we are trying as a department and a course and a degree and a program, where it's almost that thing of all that stuff about being work ready. We can use that to jump off so that now we can start analyzing why this is the way things are. It also might just be fundamentally from the fact that we are trying to do an engineering as humanity at the same.
So this is the question that we're answering. Are you happy to jump over to Mick?
Yeah, so I think universities might have a different goal to an organization like UMUSI. So universities that also want to have students be work ready. However, there is also the goal of science happening at a university. So if you're going to do a CS degree, you might do a whole bunch of stuff which isn't really relevant to the work environment. Stuff like dependent type theory and category theory and all that stuff, which is important for the science behind it. But you guys don't use category theory. You guys don't use dependent type theory, and well, you might use type languages built on dependent type theory, but you don't think about type theory. Well, let's say the theoretical basis of typing systems. So there's different goals, and it depends on what you want to do. I think if you want to be a scientist, then yes, you do need a degree. But I don't think a degree is, strictly speaking, necessary to become a good software developer. What is important is to be able to deliver good quality software and to know the tools that you need to do. Tools like Git and Django and all those things, and how they fit together. More so than all the other stuff that you would get at a university. So I think it depends on what your goals are.
Lucky, do you want to chime in? I figure like you might be, so I actually skipped over a question because it felt like we touched on it, but I think you are you receive people into BBD from both both like places like mine and like also within code and that sort of thing, and also like universities. I don't know if you receive any self-taught coders. Maybe you do, I'm not sure. So what do you like? What do you think the point is of these different kinds of ways of being educated?
Yeah, I've been largely covered by Tim and Mick in that the goals are different. On the other side, when they come in, what we see is that one of the most critical things that you need to be able to do is, in my opinion, be able to understand where your gaps are and to be able to learn and be teachable, which sounds obvious, but you'll be surprised at how many people come in lacking that understanding that this is just the beginning, right? And what we see from an exposure or experience perspective is that people that come from universities will have a very deep understanding of concepts and systematic design and how to put things together, and limited exposure, particularly from engineers, even more so than computer scientists, to the sort of like breadth of tools that are out there, right? So people will come in and say, yeah, I know C++ and Java, and that's it. Whereas on the other spectrum, we've got people that have played around with everything, but without really engaging on a deeper level, which means that they can build something that works, but as soon as we get to the enterprise level complexities of how we deal with things, that's where things start falling apart. Whereas from your university grads, what we're experiencing is that things that you would assume every developer knows, like Git, right? That knowledge isn't there because they've never had to build software with other people, and source control was never a big thing. Personally, for me, when I started working, I had almost no exposure to databases. And in my first month, I ran a query on a production database because everyone around me assumed I knew what I was doing, right, for a bank. And I did it, right? And it went on. Everyone just assumed, oh, he can code. I mean, surely he obviously knows databases. And I think it was only in the following year where I actually took my first database course and not just following the patterns that I was seeing in the code base. So these are the gaps that we are seeing. And yeah, we've got ideas as to how to try and bridge those gaps. But I think fundamentally, when we're looking at building large systems, people will have different strengths. Because people are generally different, but their backgrounds also give them strengths in different things, where your formal education, as the previous speaker said, will focus on understanding why we do things. How did we get to where we are now? Helps you build a much more robust system because you understand how to put these together. At the same time, we need you to build this thing. Do you know this tool or not, right? And if you don't know this tool, we now need to spend 2 weeks making sure that you can learn this tool before you can actually have an impact on it. So they both have their pros and cons.
Wits, do you want to take over again?
Yeah.
Maybe an audience question?
Cool. I feel like your answer, though, just dovetailed into another good question. So I'm going to ask that one, and then after that, we'll go into audience questions. So not all students start from the same base. How do we go about getting the inexperienced up to speed without boring the experienced?
Yeah, that's hard.
Sure.
That's my question. So maybe I should start with my my view of it is this is a problem that I experience. So for example, every year I get a cohort of 600 students. Some of them have had a computer all their lives, and others only just got their first laptop. So there is a huge gap in experience levels. So now I am faced with the dilemma of trying to get the inexperienced up to speed while not boring the guys who've been guys and girls who've been coding for years. They're doing C++. They're doing things more difficult than Python. So now I'm faced with the problem in getting the levels let's say equal without boring the experienced people. And I think I have it lucky because I don't teach software engineering. I essentially teach coding for science. So there's a whole bunch of you can hide the boring parts to the experienced guys and girls by emphasizing the scientific problems and saying, oh, well, you've got the coding experience, you can code this up, and usually then what the experienced people do is they just run with it and they start doing their own thing and experimenting and playing with it, which is the right way to do. Another thing that I also would like to mention, and what is in here in brackets, is I feel, or my experience is, that economic inequality is a huge barrier. South Africa is the most unequal society in the world, and I feel it in the classroom. That the students coming in, they're not stupid, but because of economic disadvantages, some are just further ahead than other ones, purely through economic disadvantage. For example, well, you can think if at 18 you get your first laptop, you're thrown into a coding class, you're going to have a tough time, and it's not because you're stupid. It's just the way it is. So economics. That plays a major role, or is my experience of it.
I think something that would be kind of cool is to discuss how, like, we can all start sharing resources. Like, if there's a basic computer literacy course that could be given, I think trying to come up with maybe even something as simple as a blog post, a static website, like a page on maybe one of Umuzi's sites or something, where we can start to link some of that, like, upskilling stuff, so that when you realize people, or even like maybe linking a questionnaire, like figuring out which level are you at, and then sharing resources to get people to roughly the same base, because I think maybe lecturers at university level are experiencing that problem at scale. But sorry, to answer, like, to get other people's opinions, Sheena, what do you think?
I think it's a hell of a hard problem, and I often deal with students who have been, like, really beat up economically. Like, I deal with kids who are the breadwinner of their household, and now they want to learn how to code, and I think that's brilliant because it means that they can actually look after that family. But it's a tough thing. Like, some people, like, they don't have bandwidth for all of this stuff. They, like, learning to code is hard. They're new to it. It's like a scary, difficult thing. And, I have to look after my siblings, so that's very tricky. We have a couple of different things that we try. So the one is self-paced learning, as much as possible. So with us, we're all remote and stuff like that. And basically a person's syllabus is represented as like a Kanban board, and they get to move cards across the board and, work on projects and get them to close, and that's great. And I think that helps a lot, because it means that if somebody is, like, slower than the rest for whatever reason, they're just, like, doing their normal thing. They're not highlighted as somebody who needs to keep up with the group. If we do track them, though, like, if somebody is falling behind, we'll let them know, like, hey, you actually need to move a little bit faster on this, but we'll also make sure that we can work to give them some extra resources. So by allowing people to be self-paced and by keeping track of where people are, we can see who needs the help and give the help to them. The other thing that we like to do is, like, we have, like, it's really hard. We have these things called JTLs, junior tech leads. And basically, like, if somebody is very responsible and they're, like, doing well in their projects, then we give them the opportunity to support others. So a junior tech lead will go and be a part of a stand-up for another group of students, and they are there for a bunch of different reasons, but we try to simulate the tech lead role as much as possible. So they're listening to what like technical issues people are having, and they're, like, helping to unblock things, and they're also acting as, like, bullshit detectors, because sometimes that's necessary in education places. So they're super helpful, and like, our JTLs tend to get hired into better roles when they leave us. Like, if we tell an organization, like, this was a junior tech lead and this is all the stuff they did and all the ways that they helped, and they're like, okay, cool, like, yes, please, we'd like this one, please. So that's awesome. And then on top of that, there's stuff about just anything that we can do to facilitate knowledge flow from one brain to another is a big deal. So we run a lot of different experiments where we like group people together and we're like, sweet, you're a team. Now you all need to get to a point where you all understand this thing and see if that works. And so we've got like lots of like things like that we're trying out that seems to even the playing field a little bit and frustrate some people. Yeah, so there's a lot of experiments. I think that's everything. I like the idea of having shared resources where people can assess their own skill level. So our syllabus is completely open source, and like it's a little bit messy in places, but it's there and it works for us very well. And there are certain parts of it where it's like, at this point, you should understand these things, but it might make sense to add in some more basic stuff. Yeah, so that's a very good idea. Thank you.
Sheena, would you mind to post the links to those repos so that everyone interested, I'm sure the people that are in this room are quite interested in technical education and might be interested in contributing to those repos. Cool. Tim, thoughts?
Sure, 100%. I think it's reflecting sort of the both of the things that I've mentioned already. I think the one thing that's sort of interesting that's popped out to me is there's an exposure access and education access, which feel like that might be able to distinctive, because one thing there is the scenario of students who've only been had access.
Is it Tim or is it me?
No, I think it's Tim. Sorry, Tim, 1 second.
Your network is doing something very weird. It's hard to make out what you're saying.
Oh no. Yay, listening to what a time to be alive. Cool. Am I stable now?
Yeah.
Seems like it, yeah. Maybe.
Cool. Yeah, so I think it might be useful to separate this education and exposure access that I sort of got gleaned from what has been previously said. Where obviously with the exposure access, there's the obvious issue of familiarity with the materials at hand, the computer, the operating system, etc. And that is definitely certainly that issue. And we try to mitigate some of that at our department by trying to provide all the students with the high-end laptops that can sort of provide them with enough resources to push their game much possible. I think that's quite interesting that I've basically heard from my entire from an education access perspective.
Sorry,
is
Tim.
the ways in which
it's going bad again.
I
feel like there's a correlation between hand waving and internet speed.
Yours is also kind of weird.
Maybe try turning off your camera, then we can at least hear your voice. So there we go.
Yeah, that might be effective. Yeah, I'll move over to using a hotspot now that Wits has let me down once again. So so the thing that I've heard from the undergrad is for students who have been programming and working with computers for many years before they started being educated by us, is there's actually an interesting situation where the process of unteaching them the mistakes that they've picked up in their formative years of learning these things is a harder process than teaching someone who's starting from scratch. Personally, for me, I do. Some students are able to overcome it. Other students seem to surprisingly be worse than their peers by the time they are leaving the program for some reason. They're not incapable and they're not inadequate, but it's weird. It does seem to appear that their momentum slows down through that process of having more access to these things at some point. I think similar to you, Mick, where that engagement issue is definitely somewhat of a problem, specifically in the very beginning. There definitely are students who are tired of learning what an if statement is and a for loop is, etc., etc. But I think also in the context of the fact that we are teaching people to make games, and so we are simulating spaces, simulating physics, and the process of building graphical representations of these things, that application process becomes a lot clearer and exciting for them in the first place. How do I make this thing to make video games? And the means of approach, and I think in particular the way we try to approach demonstrating let me rephrase this. That even if we are doing things like teaching people basic linear algebra or basic mathematical applications, the recontextualization for students who are experienced and for students who have never seen this before does provide that engagement quite strongly for us, at least. I can't really remember my software education as much as I probably should, but I don't know exactly how much that correlates for them. And I think also the thing that is important to note here, the thing of economic equality, this is a weird problem for us to try and address. Obviously, fundamentally, as a vocation of what we do, we are trying to assist people in overcoming these things. And then there becomes the weird scenario in which I think it's important for all of us to appreciate that we can't, as our individual selves or our organizational selves, overcome the horrors of capitalism and the consequences of colonialism through just education or just through our own things. It is definitely a systemic thing that globally and etc. needs to be addressed, and which we help to contribute and hopefully are able to facilitate in our own ways.
Yeah, you definitely do. Like, I'm really, whenever I find people who want to teach people how to code, it's like sunbeams and light. Just like, it's so exciting. Which actually, I'm going to just switch to another question from the audience, and then I've got a question that's related to that I want to circle back to in just a moment. So we've got a question here from LJ. How do we deal with inconsistencies between software professionals? Other professionals have defined paths and for ensuring a base level of professionalism on the job versus formal studies. So I know this is something that David Campy was also very interested in. He's posted a question here, which we'll get to in a moment. But does anyone have anyone want to contribute to that first question? I'm going to show it here. How do we deal with inconsistencies between software developers?
That's hard as well.
Yeah, Lucky, do you want to go for that one?
Yeah, so I'm not sure I fully understand what we mean by inconsistencies in this context. Is it inconsistencies in skills and approaches? But I'll just try and answer it.
I guess. Generally. Yeah. Okay. Cool.
So yeah, people's styles are always going to be different. Having worked with very different code bases, you see different patterns and ways of approaching problems. I think when it comes to teaching or educating, you strive for what is considered best practices. But I think it's also important to expose the people that we're teaching to all of these different styles. So here at PBD, we have the privilege of having different projects at different scales. Well, some projects with 3 people, others with hundreds of developers on a project. So we are able to place these grads and juniors into these different contexts so that they can get exposure to all of these different things. But I think it also speaks to a bigger problem that we are encountering as a field, in that a lot of the training and upskilling, like the formalized ones, are aimed at juniors, and we seem to forget about intermediate developers and seniors. And so all of these things that people are picking up from the internet that might not necessarily be best practices. I mean, a very simple example is JavaScript. JavaScript has evolved from 10 years ago. So there are JavaScript developers who are building large enterprise systems with very bad JavaScript practices. right? And when you consult on a project, you look at the code base, you're like, how is this thing still intact? Oh my goodness, right? And that's because we've sort of forgotten about them and we just only focus on juniors. So I think how we sort of like raise that bar or equalize styles and approaches to professionalize them, it's by emphasizing on the idea of learning and relearning, right? You need to go back to best principles. Just because when you're a junior, you did this thing and you were great at it, doesn't mean that you're done. It's an evolving journey, and I think that's something that everyone needs to embrace.
Totally. I think it's also, I forgot to mention when I was introducing you, but you're a co-organizer for JoziJS. So being, as an intermediate and a senior developer, continuing to remain part of the community, so that you can have those kind of revolving discussions, because often if you work at a smaller company, maybe one that's not as big and like process oriented as BBD, it can be hard for people like intermediate developers and seniors to be prioritized almost because they're not the squeakiest wheels. Sheena, any thoughts on this particular topic?
No, like it's something that I battle with on the at the level of the squeaky wheels, because like, when is a junior developer work ready? I don't let them out the door unless they're work ready, but I'm supposed to judge if they're work ready or not. And it's like, it's something that irks me so much, because it's a really hard thing. Like, what do they need to know to be professional developers? They definitely need to know the different tools. That's important. And they definitely need to have some grasp of problem solving, whatever that means. And setting that bar is very, very tricky. And we try to do it around just like numbers. Just like, okay, when people get to this point, then they usually manage to stick their first job. Great. So that's where we should probably be. And it generally works out. Like most, like a very high percentage of our people end up keeping that first job. But it's different in different places. And I think it's also like a large problem across other alt education systems as well, because every alt education school has their own standards and their own idea of what should be covered. And it's just a risky business. It's a risky business for the school themselves. It's a risky business for anybody hiring from the school. So yeah, like this lack of standards is really, really tricky. And that's one of the reasons why everything we do is open source. Like, our aim is to help other code schools so that we can have a standard, and so that so that people can be predictable, because then it just becomes a lot more feasible for other people. Yeah. Yeah, that's what I got.
Cool.
Welcome back, Tim.
That actually,
Sure,
yeah,
my
welcome back,
apologies.
Tim. All good. We've actually got a question here for you, which kind of dovetails a little bit with what Sheena was just talking about. So question for David, from David Campy. Tim, you mentioned an ethical requirement for work readiness. Is there anything in place in your work to assess work readiness after completion?
So, yeah, so I'm curious about the and it's unfair to ask the person for details at this point, but yeah, what they imagine in the kind of ways in which this machine decided to, there we go, in which people imagined what kind of work readiness is expected from that. In general, the best way to answer this is that this is all built into the general assessment of what's expected of the students. In particular, the most explicit way this is done is that later courses and within the program are focused on professional practice and preparing students in such ways for the ways in which so-called good practice and professional practice is demonstrated in the work environment. And they are expected to fulfill their projects and execute their projects with using those principles. Is the main approach that we are currently utilizing to assess people's ability for work readiness at that point. Obviously, I think a caveat that's important here is that work readiness probably cannot be placed on a scale from 0 to 100. And it's fundamentally more just about looking at the ways that we have influenced the means for students to actually think in certain ways to prepare them for that work readiness skill set. I think that answers the question.
If I can add to Tim. So Tim and I teach in the same department. And I teach one of the sort of like later year courses. And the aim of reworking this course was to try and bridge that gap. And one of the key requirements is to almost do this checkbox of what do we in industry expect developers to come in knowing? Source control, right? So using Git, being able to talk about your code, right? Being able to explain to me why you wrote this line of code is an important thing. And then exposure to the tools that are out there outside of the domain of your own computer and of the Wits CNS network, right? And so what we do with this course is we say, okay, all of your essays, all of your things must be hosted on a publicly accessible website. So they must get used to the idea that what you're creating actually exists out there in the ether, and which means that you now have to be responsible about what it is that you actually put out, because it's not just on your computer or your lecturer's computer. What you are creating exists out there, and other people will actually interact with you. And I think that creates this fundamental shift in how we see what we create. In academia, it's often a sandbox where you just play around and you are experimenting. But as soon as you add that responsibility thing, people think twice about what it is that they do. And I think a key ingredient that we need to strengthen is the link between academia, the training institutions, and the industry. Because industry changes very, very quickly, while academia doesn't change as fast. And we need to keep that relationship very, very close and strong so that we can influence the curricula of all of these institutions. And I think that's why in our department, we are trying to strengthen that with people who work in industries.
Absolutely. Mick?
Yeah, if I could add there, yes, academia can sometimes be a little bit outmoded, slow to change, slow to adopt new technology, slow to teach them. So that is something that we should be aware of and definitely communicate with industry. It doesn't help if we're teaching Fortran to thousands of students if industry has no jobs for Fortran developers. Doesn't mean that Fortran is bad. It just means these developers will not find a job. So it's important for academia to stay up to date with what is available. And another thing, another thing in the vein of work readiness, which I don't think, and it's nothing to do with coding. I think society doesn't place enough emphasis on it. Is society at large the idea of clear and proper communication, being able to communicate properly? That is the basis of being an effective knowledge worker, being able to communicate effectively. And I don't think that there's enough emphasis placed on it. For example, science graduates, they're not required to do a course on communication. Where if you're doing science, you're going to have to communicate your work. If you're working as a software dev, you're going to have to communicate with your other team members. Communication, and we don't place formal emphasis on it. We tell you, well, you get all these technical skills, and we shove you out the nest. And now you can hardly express. You're a super dev, but you can hardly express yourself, and you can't work in a team, and you don't have those soft skills, and you have to kind of pick them up, and you kind of pick up bad habits along the way in your communication.
Yeah. Maybe that's something that universities could focus on. If the fact that they can't move as fast as industry in terms of teaching people modern languages, they could focus maybe on skills that are very adaptable and general in addition. I have a question. We're running out of time and I wanted to ask one question. Okay, so this is my one. How do we look after lovely people like yourselves who are willing to teach, like you just like, yeah, how do we look after senior developers and or people like yourselves who are actually like educators as well? And I think this is probably very relevant for a lot of people in the audience who sometimes struggle to get their work done, as well as upskill people, and they find it really stressful. And so a lot of people want to be an individual contributor without looking after the team necessarily, but like that's if you end up finding yourself in that position, any tips and tricks for keeping yourself mentally stable and like making sure that you're in a good space to actually teach and upskill people? Who wants to field this one first?
I'll go.
I can. Go for it. Yeah.
Yeah.
Tell us your ways.
Yeah. So it's a multi-pronged solution. So I think on a personal level, it's important to compartmentalize what it is that you're doing, because it will drain you. So, for instance, I've got about 3 juniors on my team at the moment, and every day I have a set time for them where I know that in this hour I need to spend it with them and making sure that everything that they need comes there. And having that set time, almost like a stand-up, makes sure that they can also prepare for it, where if they're stuck, they know how to or what to go and look up and come to me with some possible solutions. So being able to schedule that time helps a lot, rather than being disrupted and having to context switch multiple times a day. So that for me helps a lot. And I think even more seriously is that the organizations that we operate in have to see this as an investment, and they have to actually account for that time. So the time that you spend helping your teammates, the time that you spend teaching someone else, that is billable time. That is time that is spent investing. That is time that is spent actually contributing to the project that you're delivering. And it's not just your own time. So when we estimate the work that you need to do, those are things that we need to factor in. As much as we have to think about security and privacy and UX design and all of these other considerations, upskilling and transferring knowledge to the rest of the team needs to be one of the things that we factor into that time buffer. So we are fortunate enough to be able to have a flat structured organization, which means that these ideas can be taken up with very little resistance, and we're actually able to pull people out of projects and say, what are you struggling with? Let's see if there are other people that are struggling with similar things, and be able to intervene there. But I think there are things that your team does and ways that your team will do it that will never be able to come in and prescribe how it should be done. You need someone on the team to show you how things are done in that context, especially because we have some wild clients, right, that do things very, very differently and things in their own flavor. So it's important for the seniors in that team to be the ones that transfer the knowledge and not some external training consultant that comes in. So we need to factor in those times. So it's a personal investment, but also the organizations that we operate in have to see it as an investment as well. Without that, I think we'll work ourselves to the bone and we'll burn out. And that doesn't help anyone.
Yeah, true. Tim, any thoughts?
I'm trying to provide a confident answer, but I'm not sure I'm going to be able to do so. I think so like his basically was on the money on a lot of things, as Genevieve expected to be. And I think it is a matter of handling, so when you have 300 students, the max amount I've ever had is 80 students, so I don't even have as many as Mick might have. But I think there is obviously the consequence that our type of work is quite involved because we simultaneously tech and School of Art, and which means not only do we have different backgrounds but different cognitively, let's say, but that's not quite the correct word I need to use, but also different backgrounds, economically, etc. There's a lot of different personalities and a lot of different archetypes at play. I am not sure how to handle this with issues of burnout and balancing work. The main solutions that I have had at the moment is just to facilitate things with trying to bring those two a little bit closer together, which is generally usually the advice that is not given. Where I can use my research work as a means of trying to make it closer, make it better for students to understand what and why we are doing these things in the actual field. It's a little bit difficult for me because my research is specifically looking at systemic racism and technology, which I can bring in sometimes, but it's not the focus of the specific course that I'm teaching. But yeah, those are some of my experiences. I don't have an answer on how to avoid doing this yet. I'm still trying to learn so nobody else has to deal with it ever again.
Cool. Mick? Oh, you want to go, Sheena? Sorry.
Mick can go first. It's all good.
I will be very short. Avoiding burnout, have a strict routine. It's easier said than done, but get up in the morning, at the same time, have the same routine, stop at the same time every day. And then you have to turn it off at some point, and forget about the work stuff. That is my strategy. Turn it off. Cool. It doesn't serve you to keep scrolling at 12 at night through the questions on the course Discord and answering them. Turn it off. They will still be there at 8 in the morning.
Cool. Sheena?
Yeah, I agree with you, Mick, about routine. Like, it's one of my early warning signs. It's one of my canaries. If my routine starts to slip, then I'm like, oh no, you're heading down that bad path again. Yeah, like things are just better when there's a routine in place. Besides that, like, so I teach people, but I also have a team of coders of different flavors and data scientists who are all about teaching other people, and that's fantastic. And so I need to try and think about them and how to stop them from getting burnt out, and that's also a very hard thing. So one thing I try to do is make sure that they feel a sense of agency over the process that we have and the processes that we follow. So it's really important to me that I gather all of their opinions. And then, like, for example, we had to solve a problem about bridging courses the other day. So I was like, okay, give me all of your ideas, guys. So we like put them out on a board. I was like, fuck, that's a lot. And then I'll go and I'll take their ideas and I'll try and turn it into something. I'll be like, do you think this will work? And I base it on that. And then that seems to work really well, which is like, and then or like sometimes I'll just have like a great idea and then we'll just go do that thing. So I think like agency is a huge deal. I think another thing is letting people focus on their superpowers. So like I'm not going to ask a junior technical person to do like admin tasks around the course because that's not their superpower. They're just going to hate it. And I'll rather say like, okay, you do your best. Go teach this person how like loops work. You know, but don't worry too much about filling in a million forms about it. So yeah, making sure that the right people are wearing the right kinds of hats is very important. And then also there's some like emotional hacks, I suppose, or like so let's say, for example, I am teaching somebody and I have discovered that they were cheating on a thing. Like I used to get quite upset about it and be like, oh, why? Why did you do this? But now I'm more like, that was interesting that happened. And that lets me like not work myself up about it, but also it sets me up to help the person a little bit better, because like, yeah, people like, when you're teaching somebody stuff, they do all sorts of weird things. They have all sorts of weird behaviors, and some of those behaviors are unhealthy, and some of them are upsetting. But like you can often, just by looking at it with a curious lens instead of a judgmental lens, like it changes how you react, but it also changes how much you can help them. It gives you a lot more leverage if you just like, well, that was weird. I wonder what happened there. Yeah, I think that's it. And we have 4 seconds left. Yeah. That's all I got.
That is, yeah, well done on timing. My goodness, that was a really, really great answer. I think one thing I would like to chime in is I usually, like, if I'm feeling like I have people sandpapering me, like I feel like a lot of tiny sandpapers all over my like soul, because it's like a lot of things trying to deal with like a workload, plus people asking you questions and just like context switching all the time. I find sometimes it's also good just to try to interject some degree of like nonsense or fun, or have like something that takes the pressure off from like the tension sometimes between you and a group of people, where you just like realize you're like, okay, it's all going to be fine. Like the most important thing is preserving my energy and my emotional willingness to like keep running these projects and keep teaching people and stuff. So yeah, for anyone who is interested, I'm sure everyone here is going to be available for chats, and you can find people maybe in like a breakaway room, I think, if those are happening and people want to
Discord channel for this talk.
Yeah.
So
brilliant. So that's fantastic. And we've got lots of questions which we didn't get to. So I'm sure we can discuss them in Discord. And thank you so much for all of our speakers for being here, and yeah, for raising the bar in technical education in South Africa. It's like one of the most important things we can be doing. So thanks so much.
Thank you
everybody.
Thanks, everyone.
See you soon. Bye.